Hello, welcome to another episode of the Bitcoin Standard Podcast. Our guest today is Professor William Happer, the Cyrus Fogg Brackett Professor of Physics Emeritus at Princeton University, a longtime member of the Jason Advisory Group, where he pioneered the development of adaptive optics. Professor Happer is a founding member of the CO2 Coalition, and he served as the director of the Department of Energy's Office of Science from 1991 to 1993. In 2018, he was on the National Security Council studying the impact of carbon dioxide on global warming. Professor Happer, thank you so much for joining us. It is a pleasure to have you here today.
Well, it's a pleasure.
So, you are a highly credentialed scientist, and yet you do not have the predominant view, I would say, amongst your colleagues in most universities these days, wherein they happen to believe in the idea that carbon dioxide emissions are causing irreversible and destructive damage to the Earth's climate. So what is your position? Let's just begin from the beginning. What is your position on what is the impact of humanity on the climate? What do you think is the case?
Well, climate has always had a big impact on humanity. You can read about it in the Bible. That's why Joseph went to Egypt. There was a drought in Palestine. So climate is always going to fluctuate, and we're only talking about fairly small-term fluctuations when we look at the recent history of, say, the last few thousand years. But of course, there are much, much bigger fluctuations over the ice ages. None of this had anything to do with carbon dioxide, and the increases in carbon dioxide that we're seeing now also have almost nothing to do with climate. Few people realize how small the influence of carbon dioxide is on climate, on radiative transfer. But if you double the concentrations of CO2, carbon dioxide, you only reduce radiation to space by about 1%. It's a very tiny amount. And it doesn't take much change in temperature or cloudiness or many other factors to compensate for that. So the idea that increasing carbon dioxide is causing a runaway greenhouse effect or a runaway climate change is simply not true. It's never been true. Carbon dioxide has always changed in the past, and we're at historically low levels now compared to what the Earth has been through previously, and compared to the levels that are best for plants.
Yeah, I mean, historically, looking at the historical track record, I think it's pretty difficult to argue with people about CO2 levels in the past. Usually, when I make this argument, I think the vast majority of scientists will agree that CO2 levels were much higher in the past. But what is the quality of evidence that we have for that? At the end of the day, science is experimentation. So we can't perform experiments with time machines, as far as I can tell. So we can't go back to the world a million years ago and say this was the concentration of CO2 back then. So what kind of evidence do we have that suggests that it was in fact much higher in the past?
Well, there are a number of proxy ways that you can judge the amount of CO2 in the past. One of the simplest ways is you look at stomata in leaves. When there's a lot of CO2 in the atmosphere, plants grow leaves with fewer holes in them. They use these little holes, the stomata, little mouths, I guess, in Greek or something, to get CO2 from the air, and CO2 diffuses in. And plant really doesn't like to have holes in its leaf because although it lets CO2 in, it lets water out. And so it dries out the plant. So plants have a fine-tuned feedback mechanism, and when they sense that the atmosphere has more CO2, they grow leaves that have fewer stomata in them. So if you look at fossil leaves, you can count the number of stomata in this fossil leaf, from some swamp or something where it's been preserved for a long time. And if you see fewer holes, there was more CO2. And if you see more holes, there was less CO2 because the plant is straining to get enough CO2 to live. And so it needs more holes to let molecules diffuse into the leaf. So that's one. It's stomata. Another, perhaps the most important one for very old times before there were leaves or leaves of plants that we fully understand are paleosols. If you look at fossil soils and you look at the carbonates in the soil and you look at the isotope ratios of the carbonates, from this you're able to model amount of CO2 was in the atmosphere when the soil was formed, because some of that carbonate comes from atmospheric CO2 that diffused down into the soil. And that will have one ratio of carbon-12 to carbon-13, which you can measure very precisely. And some of it comes from the roots themselves. The roots respire, they breathe just the same way you and I do, and they release carbon dioxide that has very, very little carbon-13 in it. You know, when plants synthesize carbohydrates in photosynthesis, they discriminate against carbon-13. So the workhorse in most of these paleo estimates of CO2 is the carbon-12 to carbon-13 ratio. There are other examples of that we could talk about, but that's the flavor of it. That's how it's done.
And what about the evidence that these things are as old as scientists really tell us? So, I mean, all right, we can measure the stomata, we can measure the ratio of different carbons, but how do we know that this is really a leaf that is 1 million years old or 5 million years old or not, 500 or 5,000? I mean, at the end of the day, they all get old and they can all burn down and they disintegrate. What is your assessment of the state of evidence on that question?
Well, if they're not too old, say they're less than 100,000 years, you can use carbon-14 dating, because, the atmosphere is full of carbon-14, a radioactive form of carbon that's caused by cosmic rays. And the plants absorb this. And so a fresh piece of wood is fairly radioactive with carbon-14. But if you have a piece of wood that's been sheltered from cosmic rays for 10,000 years, it will have about half the amount of carbon-14 in it because it's decayed away. And if you have a piece of wood that's even older, there'll be less and less. So the amount of carbon-14 is really the gold standard for the recent past, tens of thousands, maybe up to 100,000 years. It doesn't work forever because it all decays away after a while and there's none left, and then you're stuck. So there are other radioisotopes that can be used for older periods, and it depends on the circumstances. If it's very old, for example, you can look at the decay of potassium-40 in volcanic glasses, and so you can find a leaf or you can find some other remains that's surrounded by volcanic ash. And then by looking at the ratio of argon-40 and potassium-40 in the ash, you can judge how old it is, because potassium-40 gradually radioactively decays, but it has a very, very long half-life compared to, carbon-14. And so by picking radioisotopes of different half-lives, you can pretty well establish what the ages of the sediments are that you're trying to study. I mean, the oldest of all are, isotopes of uranium. Uranium has lifetimes that are of the order of billions of years. I don't remember the exact number, but one of the reasons today we have mostly uranium-238, when you dig up uranium, as opposed to U-235, which is the valuable one, that's the one that's fissionable, that you can use in a nuclear power plant, is that the uranium-235 lifetime is quite a bit shorter than 238. So it's mostly decayed away from the time it was formed, when the Earth was formed. But uranium-238 has a much longer lifetime. It also decays, but much more slowly. And so there's more of it left. In the early Earth, I think there were natural nuclear reactors. There's a famous one in West Africa. It perked away with and went critical, several billion years ago, and has gradually used up most of the U-235. But long ago, when there was more of it, it's much harder to make a natural reactor today because there's not much U-235 left in natural uranium ore. But most of the dating is based on radioactive decay.
Mm-hmm.
Yeah.
And so you're a physicist, so you should know this. And, generally when talking to, I like to call them carbon hysterics, people who are driven into hysteria by atmospheric concentration of CO2. They'll generally tell you, well, this is just basic physics and you don't understand physics. You don't have a PhD in physics, so you don't know. And curiously enough, when somebody who's world expert at the top of his field in physics says these things, suddenly physics is irrelevant for climate. And I've seen you attacked repeatedly because you're not a climate scientist. You're just a physicist, as they say, which is curious because, if they're talking to a physicist, then you're just a physicist. If they're talking to somebody else, then they pull up the physics card and say, oh, well, you're not a genius physicist, so what do you know about this? But as a physicist, what is your estimation of the relationship between carbon dioxide and temperature? Do you think it is driven by carbon dioxide, that carbon dioxide drives the temperature? Do you think it is the temperature that drives the carbon dioxide?
Well, certainly in the ice age cycles, it's pretty clear that it's temperature driving carbon dioxide, because if you look at the ice cores from Antarctica, you can measure the carbon dioxide in the air bubbles that were trapped in the ice, and it goes up and down with the ice ages. So there is a lot less carbon dioxide at the glacial maxima, like we had 20,000, 25,000 years ago, than there is today. And that's been happening for 1 million years or so. That's about the maximum that you can use the ice cores. But every time an interglacial comes, carbon dioxide goes up, but the temperature changes first, so the cause is clearly the change in temperature. Temperature goes up, carbon dioxide goes up in the ice cores, temperature goes down, and, a few centuries later, carbon dioxide goes down. So it's a cause-effect relationship for sure, but it's temperature causing changes in CO2, at least for the last 1 million years. Now, the carbon dioxide going into the air today is probably mostly from human emissions. There's no evidence of this kind of increase in the ice core. However, it as I said when we began, carbon dioxide hardly makes a difference to radiation transport. The heart of this is, how does radiation get in and out of the earth? We're heated by the sun and we're cooled by thermal radiation going out. And the effect of carbon dioxide is only on the outgoing thermal radiation. It is not very big. And even if you have no clouds, and half of the earth is covered with clouds, Princeton's been covered with clouds for the last 3 days. Even if there are no clouds, where carbon dioxide has the maximum effect, it's only a 1% effect for doubling carbon dioxide. That's a really small effect.
Yeah.
And if you put in clouds, that means it's only half as effective, because where there are lots of clouds, the CO2 hardly matters at all. So my guess is that, it would be very hard for CO2, if you double it, to cause more than 1 degree Celsius of warming. And it's probably less than that. But I think that there has been some warming. Over the last couple centuries, we've had pretty good thermometer records. I think most of that is from the recovery from the Little Ice Age. The Little Ice Age ended about 1800, and it was much colder for several centuries during the Little Ice Age, and now we're slowly warming up. You can see that, for example, from the record of glacial retreats. The retreats really began around 1800, 1790. They were already shrinking, and that was long before any CO2 was going into the air. And so that was clearly some kind of a natural recovery. Exactly what it was being driven by is still hotly contested. Nobody's quite sure. May have something to do with the sun.
I mean, I would imagine that, a giant ball of plasma that is many, many thousands of times the size of the Earth is going to have a significant effect on the temperature of the Earth.
Yeah.
Just, I'm no physicist, I'm no climate scientist, I'll admit. But I mean, it'll be hard to convince me otherwise. And it seems to me completely backwards that people begin with the assumption that this tiny little trace gas is, as I like to call it, the control knob. And this is really, I think, the powerful image that once you think about it, like, why should CO2 be a control knob for the Earth's temperature? It really doesn't make sense. The sun makes a lot more sense. And small variations in the radiation that we get from the sun are likely to impact the temperature much larger. On this question, I was extremely interested when the corona lockdowns happened 2 years ago, when aviation was shut down, car driving was shut down, a lot of industry was shut down. We significantly reduced our CO2 emissions for a few months in 2020. And I think what I find interesting, I found a lot of things interesting, but I think the first thing is there was absolutely no curiosity among most climate scientists to look at this example of this experiment that we've been afforded because of the coronavirus lockdowns, where here we are, we've reduced CO2 emissions by a significant amount. I've not seen attempts to quantify how much CO2 has been reduced, and I've not seen any attempt to try and extrapolate the effect of that reduction in CO2 to the climate. I have not seen anybody go and propose a thesis saying, all right, I mean, I think this is what would have, this is what an honest scientific inquiry would have looked like. I think, March 2020, the world gets shut down. If I were somebody who believed in the hypothesis that CO2 is the control knob for the Earth's temperature, I'd make testable predictions and say, based on our understanding of climate, I would say that if we reduce our CO2 emissions by, say, 50% over the next 3 months, we're going to get this much reduction in temperature, or that much increase in temperature, or rises in sea levels, or increases in rainfall, or droughts, or whatever it is. Make testable predictions and then see whether those relationships held up. And yet we saw very little of that. We saw very little testable hypothesis, because that, even though that was an excellent opportunity to test something like this. So in my mind, that would suggest that the impact of CO2 emissions on temperature, human CO2 emissions on temperature, is likely inconsequential and insignificant, because if we could shut down an enormous amount of the world's CO2, and I don't have an estimate for how much, but I would guess it must be at least 30%, when airplanes were grounded and cars were locked up, that must cause some effect, if this really was the control knob.
Let me just say, Saif, I don't think it was as much as 30%. I should have checked, but my memory is that it was about 6%. I may be wrong about that. That's easy to check, but it was not a very big change. It was something that's small. The measurements are pretty noisy. One of the problems is, there's this huge winter-summer cycle. And when they say CO2 in the air increased by 2.5 parts per million last year, what they don't tell you is, well, yes, it increased by 20 parts per million, and then it decreased by 17.5 or something like that. So there are these enormous up-down cycles due to the summer drawdown of CO2. During the northern summer, everything is green and it sucks CO2 out of the air at an enormous rate. So CO2 really drops every year, goes down very fast, much, much faster than this very slow rise that we're observing. And then, when winter comes and fall, then CO2 levels start shooting up again because respiration continues. The soil microorganisms of fungi and stuff are still emitting CO2, and animals. And so it's with this big oscillation due to life, it's hard to see the 6% change in human emissions that I think is approximately what happened during COVID.
So what I found interesting is, first of all, I haven't seen estimates of how much we reduced our emissions. But I did look at estimates of the Mauna Loa Observatory, which looks at CO2 concentrations in the atmosphere. So first of all, you would have expected to see an impact on the temperatures of the Earth. But I think what was even more surprising, even for me, was that I would have expected to see an impact on atmospheric concentrations of CO2 because of the reduction in our emissions. Right. And yet, you look at the trend, and this is from my latest book, The Fiat Standard. You look at the trends here. You can see the screen, right, that I'm sharing?
Yes, I see it very clearly. And those are the oscillations, summer, winter oscillations I mentioned.
Yeah. So the summer winter oscillations are going exactly, I mean, it's imperceptible if I were to hide the x-axis and told you to show me where's 2020 here, I don't think you could pick out which one of these is 2020. And if you look at the long-term trend here in figure 12, again, same thing. It's increasing, and with the annual seasonal oscillation taking place, it doesn't look like human emissions are even driving CO2 concentrations, are they?
Well, I don't know what's driving it, because if you look at the ice core records, there's never been anything like this in the past few thousand years, where the records are pretty good. For example, there's a pretty well documented medieval warm period when the Norse settled Greenland and, even visited North America. And it was obviously warmer at that time. Greenland was warmer. They had farms there. They raised things like barley that won't grow there today. But there's no record in the ice core of any big increases of CO2. And it was probably at least as warm as today back then, maybe warmer. The other point I would make is, if you look at this rate that you see here, if I look at it on this slide, in 2021, it's 415 parts per million, and at 2016 it was 405. So that's 10 parts per million in about 5 years. So 10 divided by 5 is about 2 parts per million per year, right? So you have data showing that CO2 is increasing at 2 parts per million per year. Well, if you decrease that by about 6% because of COVID, then it would be increasing by, what is that, about 1.9 or 1.8, something like that, parts per million per year. So that would be quite hard to see on this graph.
I see. Yeah, but I guess the counter argument here would be that, I mean, if the people who panic about the climate do get their way, we can't really do much more than what COVID did. Like, I mean, that was massively devastating to the livelihoods of billions of people worldwide, and we're still paying the bill today. All of this inflation that's happening all over the world obviously cannot be separated from all of that. So this has been, even to just do 6% reduction in CO2 was a massive, massive humanitarian cost. We've got all these diseases that are increasing because, cancer rates and malaria and tuberculosis, and all these diseases a lot of progress was made in fighting those diseases, and a lot of it was reversed over the last couple of years because of these lockdowns. And that barely made a dent in the weather, in CO2 concentrations, and even in our CO2 emissions. So I think the case for, remaking the world economy because of taking some precaution about the fact that, maybe the atmospheric concentration of CO2 is going to ruin us all, I think is entirely flimsy. But I take your point.
Yeah, I completely agree with you that the policies that are being urged on humanity by the climate fanatics are suicidal. I mean, it's really a suicide pact, and we shouldn't do it. It just is crazy. And there is no scientific reason that we should be doing it. I mean, if anything, the one thing you can say clearly about more CO2 is that the Earth is getting greener. That's absolutely clear from satellite images of the Earth. It's clear from agricultural yields. And so a big part of our current food supply is from more CO2. If we had the same CO2 they had in 1800, we wouldn't be producing enough wheat and corn to feed the world. So we should be very grateful for the increases in CO2, and more increases will bring even more benefits from better growth of crops, better growth of forests, more abundant sea life.
Yeah, you are part of the CO2 coalition, and I have a PhD from Columbia University in sustainable development, and during the time when I was doing that PhD, I was a card-carrying member of Climate Hysteria Squad, and for me, CO2 at that time was just this evil that was going to suffocate us. And I remember the first time that I came across your website, and I thought to myself, wow, I mean, it was outrageous. It was insane. Like, those people are talking about the poison that is destroying our earth
Yeah.
as if it is a good thing. It's absolutely jarring and shocking initially when you come to it. But then I remembered, my school studies of photosynthesis, and yeah, CO2 is plant food. It's one of the least controversial scientific statements you could make. It's that's what plants eat, and so that's till today they put CO2 in greenhouses in order to make plants grow faster.
That's right. That's right. And there are several reasons that CO2 benefits plants. Some of them are kind of subtle that you wouldn't at first expect. So the greening of the earth, which is very clear from satellites, is most pronounced in arid regions. So you see desert edges shrinking, you see western US getting greener, the deserty parts of India getting greener. And that's because with more CO2, plants are more resistant to drought. We talked about stomata earlier in this show. And I pointed out that if you put more CO2 in the air, plants grow leaves with fewer holes in them, and they therefore lose less water. Right? For every CO2 molecule that diffuses into a leaf and is turned into sugar with photosynthesis, you lose 100 water molecules. Anything that allows the plant to cut water losses is a big deal. Today, a typical plant requires about 100 grams of water to make a gram of sugar. That's because of these losses in the leaves. You shouldn't need that much. You should need much less than that if it were stoichiometric. The whole thing, it's really amazing that people, I keep saying it's very much like belief in witches, because it doesn't compute, there's no scientific basis to demonization of CO2.
Yeah, it's absolutely mind-blowing. For me, I think maybe the smoking gun, because like when you're trying to discuss these issues, you're not confronted with a coherent theory that says this is what happens and here's the evidence. Because if you could make a coherent scientific theory, you'd be able to make coherent predictions from it. So you'd be able to say, all right, here's what's going on. This is how much CO2 we're putting out. And if things continue, this is what we're going to see next year and in 5 years and in 10 years and in 20 years. And of course, they don't make these predictions. They make all these models, and the models have all these scenarios that basically contain every possible temperature record imaginable. And therefore, essentially, they're unfalsifiable. So you always have this ever-shifting set of arguments that, it's going to cause the oceans to acidify, and that's going to kill all the fish, or it's going to cause the sea levels to rise, it's going to cause more flooding, but also more droughts, but also more rain, but also less rain, but more snow, more extremes, more hurricanes, less hurricanes, or fewer hurricanes, I should say. But I think for me, the smoking gun is the one that you mentioned, which is there were farms in Greenland. There were farms above the Arctic tree line today. So now it's very clear there's a point, I'm not sure at which lateral line it is, somewhere around the Arctic. There's a line above which trees don't grow. It's just too cold. Trees don't grow. But if you dig there, and people have dug there, they have found remains of trees. They have found remains of farms. So once upon a time, these places had plants growing in them. So Earth was warm enough to support plants growing at that point, which suggests significantly higher temperatures than what we have today. I think arguably more than just 1 degree Celsius warmer, right? Wouldn't you agree?
Oh, yes. If you go back to the Eocene, there were forests growing around the Arctic Circle. You can still see remains of them on Ellesmere Island. In fact, the dominant tree was the dawn redwood. And there are areas in Ellesmere Island where there are entire forests of sort of quasi-fossilized dawn redwoods that you can still make a campfire out of them. And it's kind of mind-blowing to think that you would be sitting there burning up wood that was produced 80 million years ago. But people do that, you're cold enough. I guess it's, wow. But, that of course is extremely interesting, science, geophysics, why is it that we've stopped studying these fascinating things and important things in order to focus on demonizing CO2 and driving people into poverty? And it's despoiling the landscape with windmills and solar panels. It's just astonishing that they've gotten away with this.
Yeah, I'm looking here. There's Ellesmere Island mummified forest. This is in Nunavut in the north of Canada.
Oh,
and
good
of course,
for you. Yeah, good for you. That's Dawn Redwoods that you're looking at.
yeah, and like of course, the article doesn't want to get the guy who wrote the article doesn't want to get canceled, and so he says rare mummified forest offers. So he's got his grammar all messed up. So I tend to notice people make grammar mistakes when they're fibbing.
Yeah.
And so rare mummified forest offers a glimpse into how our environment has been changed by humans, of course, because it's all our fault. Everything is our fault. But really, I mean, this is a place where you can't imagine trees having grown any time in the last couple of hundred years. So these are very, very old. Maybe it was humans who cut them down at some point, but the idea that they couldn't.
This was before primates really had taken hold. This was pre-primate, much less pre-human.
Yeah, and I mean, even if we were to say, all right, well, all of this carbon dating stuff is suspect, and even if it was humans who burned them down, humans are powerless to stop plants from growing back, I think, and that's the key thing. The idea that pre-industrialization we were affecting the weather up to the point where we could stop plants from growing in the north of Canada, I think is a bridge too far for even the most anti-carbon dioxide fanatic to contemplate.
Well, I hope so.
But you never say never.
Yeah.
It's mind-boggling for me. If thousands or millions of years ago we had those trees there, and Earth survived enough for us to come out of this, whatever was going on back then it did not stop us from being here today, being able to have this conversation and have all of these incredible technologies that we've built. Seems to me like anything that we can do with industrialization is going to pale in comparison, because it's going to take a lot of, even by the most fanatic, exaggerated estimate of the impact of CO2 on temperature. We're going to need to burn a lot of fuel and oil and gas in order to get to the point where we can bring forests back to Nunavut in the north of Canada. What did you say?
Yeah, that's true. Nobody really knows why it was so much warmer then, but it was certainly not due to CO2. It clearly had something to do with different circulation patterns in the ocean and in the atmosphere. It's too bad that you can't get money to study that, because that's much more important and more interesting than this nonsense about CO2, which is it's a trivial thing, except for the good things, which are increasing plant productivity. But it really is not having any effect on climate to speak of. And it can't, for very basic physics reasons. I know this better than most. I know about radiation transfer a lot better than most climate scientists do.
Yeah, no, I would agree. And I think, the other good thing about carbon dioxide, which isn't mentioned, so yes, it does green the world. But of course, also, it does keep us warm and allow us to survive the winter and allow us to have electricity and to have houses that can withstand storms and build all of these amazing technologies that have made our lives so much better. I think, of course, the biggest glaring error here is this, the idea that CO2 only has downsides. It's boiling the oceans, it's acidifying the oceans, it's increasing global temperature, it's making the Earth uninhabitable. So you exaggerate the downsides, and on top of that, I'm not saying you, they exaggerate the downsides, ignore the positives of greening, but I think most importantly, they ignore the positives on human economic flourishing. Our life without mass emissions of CO2 would be a lot poorer. And I think, of course, it's always striking to me that none of the people that are very, very angry about the emissions of CO2 are willing to live a life that reduces their CO2 emissions. They want you to do it. They want to pass laws that ban it. They want to pass taxes. They want to be in charge. They want to get to centrally plan. They want to get to force you to drive an electric car or force you to use this and that or the other thing instead of that. Use all these unworkable, inferior technologies instead of the more reliable things that we have. But they still want to fly in their airplanes. They still want to use computers that are impossible without massive amounts of coal burning and massive amounts of industrial processing, and all of that needs to be ignored. And we want to only focus on the massively exaggerated idea that CO2 is driving temperature in some kind of crisis.
Yeah, you're right, Saif. Let me go back to one of the things you mentioned, which was ocean acidification. And again, the people who talk about this haven't got a clue of what acidification is or what CO2 does in the ocean, but approximately 50 times more CO2 is in the oceans than in the atmosphere. And we should be grateful for that, because it's the CO2 that has turned the oceans from basically drain cleaner. Ocean is essentially a sodium hydroxide solution. It's extremely alkaline. It's about the same alkalinity as household ammonia. pH without CO2 would be about 11.3, which is extremely caustic. The only thing that makes the oceans livable is the enormous amount of CO2 that's dissolved in them. And life depends on that. Without the CO2, the oceans would be uninhabitable. So there are many good things that CO2 does, and yet all we hear is carbon pollution. It's absurd. It's really absurd.
I know, and this is yet another one of these fields of research in which a lot of money has been plowed in, and a lot of preconceived notions have been validated by supposedly scientific studies. And upon closer inspection, recently, it became pretty clear that a lot of this evidence is pretty shoddy. So these two scientists have looked into, this is an article from science.org. These two scientists went and tried to replicate some of the worst results about ocean acidification, and they found that basically this has been massively exaggerated. This is a very interesting article. And it's a very common thing that you find in all of these sciences. In all of these things, like there's a conclusion that they want to arrive at, and the conclusion is crisis. The conclusion is things are bad, things are going to be really bad, and the only way for you to atone for your sins is to basically give me more money to study things, and more money to control your life and do it. And it's at a certain point you can't ignore the pattern that you see with all of those things. Wouldn't you agree?
I agree. Yeah, it's really disappointing that the educated people actually seem to be in worse shape with respect to these superstitions than the ordinary people. My taxi driver and my barber have a lot more sense about climate and climate change than my academic colleagues, and especially people who work outside, farmers and folks like that. They live with the climate, the real climate, not something on a computer screen. And they know perfectly well that every year is different. And some are warmer, some are colder, some you get more rain, some you get less. To the normal person, that is second nature. But to the highly educated elite, who's gone to prep schools and to the best Ivy League institutions and has never hoed a row of corn, it's just beyond them. They can't grasp it.
And there's this tendency and temptation to need to find a smart justification for anything. I've got a degree from this university. That means I can explain everything. So, it's rained a lot this year. Well, let me tell you why it rained a lot this year. Well, no, it's always going to, we always measure rain, and we're going to get an average, and we're going to get some years in which it's below average, some years in which it's above average. Some years are going to be massive outliers on the one side. Other years it's going to be massive outliers on the other side. In any natural phenomena, you're going to get this kind of variation. In some phenomena, you're going to get extreme variations at some certain points. This temptation that we need to find a justification for it, I think, is behind a lot of this. But I don't think it's the only thing that's really driving all of this. So I'm curious now, I think I'm very curious about your experience and your impression about why is this groupthink so dominant in modern academia? Why is it that so many professors who really should know better continue to do this? I mean, this is something I've speculated about and I've written about extensively, and I analyze it from the economic perspective, but I'm curious to hear your thoughts.
Well, I don't think it's a new phenomenon. I think academics have always plagued by groupthink. I recently looked up the witch hysteria in Germany, and it started in the 1400s, just before the Protestant Reformation, I guess I should say. The entire faculty of theology at Cologne signed this preface to the Malleus Maleficarum, the hammer of the witches, saying that witches are really an existential threat to civilization, just like climate today. And it was unanimous, every single one of these people. And they complained that there were all these silly people out there who wondered whether there really were such things as witches, and they even had the nerve to preach from the pulpit that you shouldn't be hanging witches, that this was not a good thing.
They denied the science of witches?
The science of witches. Yeah, it was a science. They had journals, they had, important papers. And, when we had the witch trials in Salem in Massachusetts, 1690, that was a lot later than, the Germans. So we should have learned something in those centuries, but we didn't. And every one of the judges had a Harvard degree, every one of them. And, Cotton Mather was busy selling a book, on how to detect and hang witches, during the trial. He made a lot of money.
Wow.
So this is not new. Academia has blood on its hands, and it always has.
Yeah, and I mean, it's really the biggest example of not learning from history, to imagine that we've learned all of these lessons from history and that somehow we are all so very different from our ancestors who were around doing all of this stuff over 100 years ago. I mean, at the end of the day, all of the people that are alive today came from all of the people that were alive back then. So genetically, we're not very different. The people who were hanging witches, they made children who today are among us. And so we're not much better than them. Sure, we've invented a lot of technology. I think I'm a big fan of technological improvement, and I think, particularly hydrocarbon fuels have absolutely transformed our lives.
Right.
And allowed us to live in a way that most of our ancestors can't imagine. The number of things that we take for granted, like being able to stay warm in the winter, is astounding. But that has not changed us. We've hundreds of years of invention and innovation and capitalism allowed us to develop this technology and popularize it and make billions of people worldwide comfortably survive the winter. But that hasn't changed our inner wiring. We're still the same group of people that would hang witches and that would go crazy over all kinds of hysterias. We're not better than that. And you don't need to posit some kind of giant evil conspiracy to get to the point of, well, why do all of those people believe that? And this is another one of the things when you're trying to argue with people who believe the earth is ending, the Chicken Littles of climate, is like many of them don't even understand the science, don't even want to understand the science. They don't care about it. And they'll just tell you, so how do you explain that all of those people are wrong? Well, I don't have to. Ask them. The idea that just because the mob is going along chanting something, then, they can't all be wrong. 100 out of 100 mob members agree that witches need to be hung. So where is your... what is your counter argument? How do you explain all of them being wrong? And the answer is, I can't. I don't have to. It's not up to me to explain why they're wrong. It's up to them to explain why they're out there in a mob calling for lynching the technologies that make our life possible.
No, you're right, Saif. And it is kind of discouraging. You would hope that with better education that we wouldn't have this kind of problem, but actually, as we've discussed, education seems to make it worse, actually. It doesn't make it better. So
I think the key word is better education. I'm not sure education is getting better.
Yeah, well, maybe. I don't know what you do about it. Going back to Salem, many of the common people in Salem were against the witch trials, when they were hanging a particularly popular preacher, they threatened to actually lynch the hangman instead of the the alleged witch. But for example, they said, let him say the Lord's Prayer. If he can say the Lord's Prayer, witch can't do that. And of course, this poor guy said the Lord's Prayer perfectly. And then Cotton Mather, the guy selling the book on how to hang witches, rode up on his white horse and waved his sword to threaten the crowd and said, hang him, it's the devil speaking. So they hung him. Right. But it was driven from the top. It was driven by the educated people. And it was the common people who had the good sense and the humanity to object.
Well, I did not know about the Harvard role in the Salem witch trials. I mean, I'm the biggest anti-fan of Harvard there is. I think there is no more damning indictment of somebody than saying that they're associated with Harvard. Generally, it is the worst marker of quality. And I think, their track record with economics, the economists that come out of Harvard are the absolute worst. The nutritionists that come out of Harvard, I think, are the absolute worst. And I think you could make the same case for many, many scientists. So now I can add the Salem witch trials to the long list of distinctions that this incredible institution has bestowed upon the world.
Well, there are exceptions. There are many very wonderful people who've come out of Harvard, but a lot of bad ones too. And that's true of every university, certainly true of my university here at Princeton.
What good people came out of Harvard? Can you name one? I can't.
I think in the hard sciences, for example, people I really admired, the physicist Pound, who invented magnetic resonance, or, so I think the further you get away from policy, the more academia has to be proud of. I'm a little unnerved about that, given what happened during the COVID, episode. But in general, the scientists at Harvard have been very good. And they've had some spectacular astronomers, for example, at Harvard, Lyman, for whom, Lyman alpha radiation is named. So they can be proud of their science.
So what is your assessment of science in general in the modern university? Because here, let me tell you how I come at this. I was doing my PhD in sustainable development, which was, we studied climate and we studied natural sciences, but primarily the course was in economics. And so my area of focus was economics. And during my time there, I became pretty disillusioned with the way that economics is taught, and I came to the conclusion that a lot of it is not very good, to just put it mildly. Then later on, I looked at nutrition critically, and I came to the conclusion that what they tell us about food is horrible. It's primarily driven by industrial producers and by inflationary monetary policy, which is where the economics comes in that, as inflation goes up, prices of food go up. And the way to fight inflation is for government to tell people, hey, you don't need to eat meat and all of the nutritious things that make you strong and healthy. Here, try some of this cheap industrial waste instead. It's actually good for you. So I think a lot of nutrition science is driven by the propaganda, but the need for propaganda to tell people to eat industrial waste. With climate, I've come to also be very skeptical of a lot of the climate scientists because, again, this chicken littleism. And then with COVID, I've come to completely distrust the field of epidemiology, which I believe is also another form of pseudoscience, because these people come up with graphs and numbers and think that diseases come pre-programmed, as if we're playing a game of SimCity, and so you're going to have to kill this many people for the disease to go through the society, and that's not how it works. Health is an individual thing. If a society is all healthy people, COVID would have very little success killing many of them. If everybody's metabolically unhealthy, COVID is going to kill a lot. These kind of things are ignored in epidemiology, where they like to look at an aggregate from a macro perspective. And that you find it in macroeconomics, you find it in epidemiology, you find it in nutrition, and you find it in many of these sciences and climate. And I think what drives it is the need for policy. It's driven from a policy maker's perspective. And I think this is just a way to corrupt scientific inquiry when you come at it from the question of what should the policymaker do? Because the answer almost always is the policymaker shouldn't be doing anything. And therefore, if you need to find something for them to do, you're going to try and torture the data and torture the theories until you can come up with something.
Well, I think you're absolutely right. There's a nice story about that, where some, satrap in ancient Persia died and he went to heaven, and Zeus said, well, what did you do when you were on Earth? And the satrap said, well, actually, I really didn't like working very much. I had this nice cushy job, and I had my assistant, sign all the papers and take care of all the business. Well, what did you do? Well, I ate and I slept, and I really didn't do anything. And Zeus said, great, come into heaven. And, Mercury says, what are you talking about, Father Zeus? How could you do that? And Zeus says, just think of the damage he could have done with all that power if he had been serious. So, people can cause a lot of harm if they're trying to, do a job, but when there's no work really to do. So they make work, and it actually causes more harm than good.
Oh, I agree. But what is your assessment of the hard sciences? And do you think that they are getting into the same kind of problems? I'm no physicist. I don't claim expertise in physics, but
well, maybe I'm prejudiced. I think so far physics is doing okay. They're addressing fascinating problems. To my mind, the most exciting one is the missing matter. What is it that holds the galaxies together? Dark energy, dark matter. So there are wonderful problems out there, and the best and the brightest are working on problems like that. Fortunately, they don't have very much to do with policy. So, policymakers could hardly care, what dark matter is. And so I think the further scientific disciplines are from potential policy, the healthier they will be. And pure mathematics, for example, is pretty far from any policy. And so I would say the most basic parts of science are still okay, but those that overlap with policy are in deep trouble because they've been sort of hijacked by people with agendas. They're really not interested in scientific truth. They're interested in getting agenda support, with so-called science. And so science gets invented to support this or that. Sometimes maybe it's worth supporting, but many times it's not. It's just, wasting people's time and money, freedom,
Yeah. Well, what are your thoughts then on the IPCC? That's about as policy-based science as it gets. What do you think of this as an organization, and what do you think of their reports?
Well, I think some of the science, especially in the early IPCC reports, was very good. If you read the scientific sections, it's honest, it's quite modest about claims of accuracy and reliability. They were quite clear that many things were very uncertain. In fact, the first 2 or 3 reports said there's no evidence actually that humans have anything to do with the climate. But then after a few years, it was hijacked by the same, policy zealots, and then the quality began to go down. I think every year they come out with a new report, and every year it brings less credit to the scientific parts of IPCC, but it certainly started out well. There was some good stuff in the early reports. The scientific parts, again, I stress, I'm not talking about the policy.
Yeah, and so currently, do you think their conclusions are justified by the data in terms of, and of course here it's very difficult because the reports comprise many studies, and I think the more people dig in, the more they realize that as you go from laboratory to press release, the sensationalism goes up and the rigor goes down, right?
Mm-hmm. Well, IPCC has a problem. At least their leadership thinks that they have to maintain this crisis atmosphere, that the world is coming to an end. I think a number of the participants, the scientific participants, are honest enough to sort of know that that's not true, but they're afraid that they'll lose their jobs if they speak up. The problem is that, it's really not warming nearly fast enough. Yeah, I'm sure that, maybe it's warming at 1/10 of a degree per decade, but that's a third or so of what has been predicted. So the models are clearly just completely off. They're running much too hot. And nobody knows how much of the warming that we're observing is due to CO2. As we discussed earlier, probably some good fraction of it is just natural recovery from the Little Ice Age, which is still going on. That doesn't happen immediately. So I think they know they're in trouble. And I think, the smarter ones are hoping that they will retire and be indemnified against, prosecution for fraud, before it becomes obvious that it was a scam. And so they can keep juggling this for just another, 10 years, then they'll be safely retired.
Yeah, but I mean, I think they're now at the point where they need to start worrying about the fact that their hysteria might end up costing them electricity and the warmth this winter. I mean, we're in a world now where Europe is really staring down the barrel of a gun that is the next winter. Sure, of course, the geopolitics of the situation and the destruction of the Nord Stream pipeline are obviously a huge part of it, but they are not the cause of Europe's problem. The cause of Europe's problem is the reliance on Russian gas and the reliance on Nord Stream, which was driven by decades of really CO2 hysteria. It was driven by the idea that we are going to move away from reliable 24-hour energy sources to use these unreliable sources that have been consuming mind-boggling sums of money. I mean, it's truly astounding. Germany alone has spent about $500 billion on wind farms, which is just astonishing in terms of subsidies. Just the subsidies that they've paid for this is about $500 billion, which is enough to build roughly gas capacity for Germany twice over. Like with $500 billion, you could get 80 million people in Germany, and you could give them all gas plants that give them gas twice. Or you could do it once and then with the rest of the money buy the gas or excavate the gas. I mean, if you think about it, I don't support government central planning, and I don't think this would be a good idea. But I mean, the government that can blow $500 billion on wind farms could have blown it on gas fields and gas plants, and then today nothing happening with Russia and Ukraine would affect German consumers. They'd have their own gas fields, they'd have their own gas pipes, they'd have their own gas plants, and they'd have the cleanest source of fossil fuel out there, and they'd have 24-hour electricity, and they'd be warm in the winter. And instead, they're facing an absolute calamity. And I think it's gotten to the point now where people need to really, I think, wake up, because up until a few years ago, I'd grown skeptical about this since I finished my PhD, but I just was not very interested in it, because I thought, who cares? A bunch of people like Al Gore are going to get rich off of this. T. Boone Pickens is going to make money from his biofuels and windmill stuff. A bunch of smart entrepreneurs are going to capitalize on this, make a lot of money from subsidies, and all right, who cares? A lot of people are making a lot of money from all kinds of different things. But only in the last 2 years or so did it become clear to me that it's not just that they're paying these people some money, it's that they're dismantling the reliable infrastructure that is the basic building block of our civilization. They're basically taking the solid foundation on which all of our civilization rests. Everything that we've built over the last 500 years, all of the technologies of the last 500 years have come from burning coal, oil, and gas. And if you vilify these because of some insane hysterical fear of these gases, we can't keep all of these extremely advanced products that are built on top of it. We can't have laptops and smartphones if we don't have massive coal, gas, and oil plants. There's just no way around it. And this is the dangerous thing about it. This is why I think this is why I've been emboldened to speak about this, even though I get a lot of abuse about it, and I get a lot of, stay in your lane, and what do you understand? And but I don't care. I used to live in Lebanon, and I saw a grid fail in Lebanon. I saw the grid get worse and worse and worse until it got to the point where it became unlivable, and I left Lebanon because of that. And at this point, the reason I'm obsessed with this topic is, from a very selfish perspective, I'd like my children to find a place in this world where they can grow up, where they can have 24-hour electricity and not have to spend every day of their life worrying about electricity, because I've lived that, and I know just how absolutely destructive it is for your productivity, for your happiness, for your security, to have to wake up every morning and think about where your electricity is going to come from and what time is it going to come and how to structure your life around that electricity. That way of living versus the way of living where you just always know that any switch you flick is going to give you what you asked of it is just an enormous difference. And if anybody listening who doesn't appreciate this difference, I hope you never have to experience it. Unless, of course, you're calling for the dismantling of hydrocarbon infrastructure, in which case I hope you do, because maybe that'll be the wake-up call that you need.
Well, are touching on an important point here, which is that these crazy things often have to have a crisis to end. Something a little bit similar happened with, say, the eugenics movement, which was very popular in the late 1800s, early 1900s in Great Britain and in the United States, other parts of the world. At least in the United States, it spawned a whole generation of eugenics experts. They were all frauds, it was all nonsense. But they had journals, they had scientific meetings. Every little town had a eugenics club, and women would go there every Thursday and wring their hands about the ruination of the good old Anglo-Saxon race, and how all these dumb, foreigners were coming in, low IQ Eastern Europeans or Chinese and Japanese. It was just complete fraud, but everybody bought into it. Alexander Graham Bell was a supporter. The presidents of Harvard and Princeton and Stanford supported eugenics. And there were many people like you back then who said, look, this is nonsense. None of the alleged science is true. You can see it's obviously wrong. But it didn't make any difference. So it was not cured by sweet reason. It was cured by the Nazis taking it over and then taking it to the extreme. And so after that horrendous experience, eugenics finally had to own up to the fact that it was mostly nonsense. And but it's a terrible way to end a sort of a fanatic movement in humanity, that it has to end in a crisis like that. But this may be necessary for the climate nonsense, that some country, or maybe Western Europe, maybe California, maybe Australia, will have to do everything the fanatics demand, and then the world will have to witness what happens.
It's looking like it's going to be Germany again. It's looking like it's going to be the famed efficiency of the Germans that's going to take these insane ideas to their logical conclusion.
Yeah.
They have pursued insane deindustrialization with the same efficiency with which they have pursued their industrialization. I mean, German efficiency is world-renowned, and dismantling their efficient, productive infrastructure, they've gone to the point of dismantling nuclear weapons as well, nuclear plants as well. And now, I mean, they have $500 billion, $500 billion worth of windmills, which are basically silent and producing nothing for many, many parts of the year. And
they don't just dismantle these reliable plants, they dynamite them, they blow them up. So you can't go back and use them again.
Yeah, and I hope it doesn't become a humanitarian crisis, but it certainly looks like it. It certainly looks like it's going to be a very, very ugly winter. And I mean, I don't know. Obviously, a lot of people die every winter from the cold. This is just always the reality. Thousands of people, or I think it's about 4 million people every year who die from the cold. It's just always the case. Cold is no joke. And so Germany's cold, of course, is also extremely strong. So this winter, if it is a harsh winter, it could be absolutely horrific. And I wonder if that's going to be the kind of wake-up call, because I can see a shift in people's consciousness on this. There was a time in which, you couldn't get invited to dinner parties if you said you thought wind energy was silly. Now it's becoming more and more common that a lot of people are saying, would have been nice if we weren't so reliant on the wind blowing in order to have electricity, now that we want to stand up to Russian invasion or so on. So people are beginning to realize, the sun doesn't shine 24/7 and the wind doesn't blow 24/7. And that renders all these solar panels and windmills essentially superfluous, because you need to build reliable capacity that matches demand 24/7 and can meet the peak demand, which can happen. You could get peak demand at a time when solar and wind are contributing zero. So you need to build a capacity with reliable energy sources. And that means that everything that you're spending on unreliable energy sources is just an extra cost. It's not saving anything. One argument I thought was the redeeming argument for it is that, well, at least when the wind is blowing and the sun is shining, you're reducing the amount of fuel that your nuclear or coal or gas plants are consuming. But it turns out that that is probably not true, because the management of these plants, apparently, what is becoming obvious now for engineers in places like Britain and Germany and Australia, is that if you just ran a gas plant independently without having to hook it into all these pre-industrial technologies of sun and wind, then you can manage the load and you can manage the operation of the plant much more efficiently than if you try and do it while, basically being at the mercy of the gods of the weather. So the sun is blowing. All right, let's turn down the gas turbines. All right, the sun is shining. Turn down the gas turbines. The wind is blowing. Turn down the gas turbine. Oh, the wind is stopped. Let's turn up the gas. Like that kind of inefficiency in managing these enormous, reliable power plants makes it much more expensive to manage them, and also reduces the life expectancy. So, it's arguably not even saving you on fuel. It's just all extra costs and degradation of our industrial capacity and our ability to provide a 24-hour grid, which is something that the majority of the industrialized world had basically conquered by, the 60s?
That's true. One of the reasons that, for example, a hybrid car gets good fuel efficiency is because they run the gasoline engine at the maximum efficiency and charge the battery. And so they don't have startup and stop inefficiencies that when you're ramping up an engine or ramping down an engine. Engines run best at a certain power level. And if you're constantly turning them on and off, the efficiency goes way down. So you may be right that there's actually no savings. And I don't know the numbers, but there's certainly not as much savings as you would think.
Very much so, yeah, and I agree. You've also done work on the ozone layer and the 1987 Montreal Protocol on preventing ozone depletion. What are your thoughts on that?
Well, that was sort of the it was sort of the practice session, for the climate hysteria, was the ozone hysteria. And that's when Al Gore got his start. And they always planned to go after carbon dioxide next. They admitted that. At that time, I was the director of energy research at Department of Energy, and we were funding a lot of that work. And I knew that, what was being said in the press was not what our researchers were finding. For example, the big worry about ozone was that if it were removed from the upper atmosphere, there would be more ultraviolet B reaching the surface. It would cause more skin cancer. And the problem with that argument was that measurements didn't show any decrease in UVB, over most of the United States, and any increase, I should say. In fact, most places it showed decreases, and for whatever the reason. And the second was there was no correlation you could find between malignant skin cancer, melanomas, and UVB. You would get melanomas on the soles of your feet, where it was never exposed to ultraviolet. So I was certainly in favor of doing something that would prevent damage, but I didn't see the evidence at the time. And so I would make these comments that, where is the scientific evidence for all of this hysteria you're talking about? I don't see it, and I'm funding the work, so I know. So, of course, that really irritated Al Gore. And so when he won the election, he couldn't wait to fire me. And I was grateful to be fired. I was able to go back to Princeton and do some honest research again.
Yeah, it's generally a thankless task to be working on.
Yeah, well, the ozone hole is still there around Antarctica. It probably had almost nothing to do with Freon. Nobody quite knows how it works, even to this day.
Yeah, I think that we just, as we were saying earlier, I think the more educated you are, the harder it is to just have the humility to say, yeah, well, we don't understand everything in this enormous, enormous planet on which we live.
Yeah.
People really want to have the idea that our planet is like our home, but it isn't. We built the home from scratch. Before this home was
Mhm.
built, it was just an empty plot of land, and then somebody turned it into a home, and every single thing in that home was put there by somebody who's a human being like us, so it's possible for us to understand it. Well, the earth is not like that. The earth was there before we were born, likely before all of our ancestors were born, and maybe we just don't have a clear instructions manual of how to handle those things. Maybe we just can't control it.
Well, we can control many things, and we've done. That's what's brought modern civilization. We've learned how to make heat engines, to provide the electricity that you mentioned, and we've learned how to give good health care, so that half the population doesn't die before the age of 3, and so knowledge really is power. But pseudo knowledge is just the opposite, right? And so that's the problem. Is that I think there's this Alexander Pope had this nice verse. A little learning is a dangerous thing. And it really is a dangerous thing. You learn things that aren't true, and it's hard to dissuade you once you think you've learned that.
Yeah, especially when it becomes an identity, as it is for many, many people.
Yeah.
Tamara has a question for you. She wants to ask you, what do you think are the biggest kinds of pollution that bother you? What are the real pollution problems out there? If the ozone and CO2 are not such calamities, are there actual pollution problems that you lose sleep over?
Well, certainly, if you go to Los Angeles, the pollution is a lot better than it used to be, but just the pollution from driving automobiles used to put lots of oxides of nitrogen in the air and, volatile hydrocarbons in the air. And so you could hardly see from one end of the street to the other. That's much better than it used to be because of catalytic converters and better control of emissions. So that's the kind of pollution that we should be attacking. Coal plants are similar. When I was a kid, I was a kid in Scotland, and we ran Scotland on coal at that time, and it was really filthy. You go to school in the morning, and by the time you came home, you were just black. The collar of your shirt was black, from all the soot and the coal, and people would, get lung problems from breathing the smoky air. That's all gone now. So that's real pollution. So we've done a wonderful job getting rid of real pollution. They don't have pea soup fogs in London anymore, but that used to be very common. So we should focus on real pollution and get rid of that, and not waste money on things that aren't pollutants at all, in fact, which are good for the world.
Yeah, and I think, the controversial thing here is that the way that people got rid of coal was not to dismantle coal plants and go back to using windmills and sunshine. The way they did that was after they used coal and got a lot more productive, they could afford to move to natural gas and nuclear plants. And that's the real energy transition that the world should have been focusing on in the last 50 years. This is what I think markets would have achieved in the last 50 years. The poorest places in the world, you may not like coal, and of course, yeah, I agree with you, it is a serious issue, but realistically, the realistic alternative to coal for most people is not some Star Trek immaculate existence where nothing gets burned but everything moves around magically. The realistic alternative to coal is poverty, and the way out of coal is, get rich with coal, and then you can buy natural gas and nuclear plants, which are much cleaner.
You can make quite good coal plants today that have almost no pollutants. I visited not long ago a ultra super critical coal plant in Texarkana, Arkansas. It's the most modern plant in the U.S., and we haven't built any since, but it was a September day, and it was beautiful and blue sky. And as we were driving toward the plant, I thought, well, the plant must be shut down because there was nothing coming out of the stack. You couldn't see anything, not even steam. It was dry, so there was no condensation from the stacks or from the cooling towers.
Yeah.
But when we got there, it was running full blast. It was burning, U.S. coal from Wyoming. And they showed us the pollution controls. And they start by getting rid of the oxides of nitrogen. When you burn coal properly, it's very, very high temperature. So you fuse oxygen and nitrogen, and some of that comes out. So they bleed in a little bit of anhydrous ammonia to clean out the oxides of nitrogen, convert it all to N2, it's just ordinary nitrogen. And then they clean out any residual sulfur with a lime bath. And then they have big bag houses where they clean out the very last particles of fly ash. So by the time it comes out the top of the stack, you can't see anything. All that's in it is water vapor and CO2. You can't get rid of those, but they are both good for the world. They're both completely natural. We breathe both of them out every breath that we take. People don't seem to realize that we're based on carbon. Every one of us breathes out about 2 pounds of CO2 a day. That's a lot of CO2, multiplied by 8 billion people. So it really worries me when you demonize something that comes from people. Does that mean you have to get rid of people?
It's a common meme that's become popular on the internet. You are the carbon they want to reduce.
Yeah.
It seems
Yeah. Well, some of them do. Some of them are quite honest about it. They say, the Earth can handle 8 billion people. We have to go down to less than 1 billion. And so which 7 out of 8 of us has to commit suicide? Or, it's a scary philosophy.
It absolutely is. And what's really scary about it is that, if it wasn't for these insane philosophies, we'd arguably be a lot richer and we'd be able to afford a much better quality of life for all 8 billion people. I think of all of the money that's been wasted on all of these renewable energy sources over the last 50 years in terms of subsidies and investments and all of the things that have been mandated for people to take part. Imagine if that stuff didn't exist at all. And then just think about if all of that money was instead spent on modernizing and improving coal, gas, and nuclear power plants. It's not unreasonable to expect that the entire planet would today have very cheap, reliable 24/7 electricity. I think it's such a, I wouldn't say trivial, but it's such a straightforward problem. And it increases people's productivity so much. If you just, build a small little gas plant, and then suddenly everybody has got electricity, and then their productivity goes up enormously. The ability to survive winter goes up enormously. The ability of premature babies to make it increases enormously. All of that really doesn't require a lot of investment. Coal plants and gas plants are ridiculously cheap when compared to wind and solar and all of those things. So imagine if we hadn't wasted all of that money on that. Imagine just how much better the quality of life would be. So ironically, people look at the impoverishment of, we've had these technologies for more than a century now. We've had power plants for almost a century, maybe. And we have billions of people who don't have access to one of those things. And then they look at that poverty, which is because they don't have access to that technology, and they think, the Earth can't fit all of us. And then the solution clearly is we need to get rid of all of us, or most of us.
Yeah. And if they want to control population, it's very clear that that's easy to do. All you do is make people prosperous. And then, women don't have as many children, and you have to kind of bribe them to sustain the population. They don't want to have a bunch of kids. It's a lot of trouble, and well-off countries, United States would be losing population if it weren't for immigration, because people don't have enough children to sustain the population. And that's true of much of Western Europe. It's true of Russia. Population growth is a feature of poverty. So if you want rational populations, then you want to make people prosperous, and you can't make them prosperous without letting them have fossil fuels. So
yeah, there's just no way of escaping that. And our next seminar, we're hosting Alex Epstein, who wrote a book called Fossil Future and the Moral Case for Fossil Fuels, which really very powerfully makes that case. And I think he's absolutely correct on it.
Yeah, absolutely.
Yeah. Nathan has a question for you on coal plants.
Okay.
Yeah, you already covered that, so I'm going to change the question to, by the way, I've read a lot of your work over the years. It's really good to cross paths. Thank you much.
Thanks, Nathan.
Are you aware of any kind of analysis regarding distribution? What for in California, with the idea that they're going to have all electric cars, assuming that somehow is a good idea, how big a wire would it take to feed electricity into LA to charge those cars? That has to be the distribution problem. I never hear anybody talk about it as if all of these tanker trucks just magically appeared one day. The energy distribution is a big problem.
No, it is a huge problem, and people just refuse to come to terms with that the California grid today cannot possibly, service all electric vehicles in California. It can't be done. And the cost to bring it up, to standard to do that is just enormous. Just the last summer, for example, people were forbidden to charge the few electric cars they had, because the grid already was overloaded. And this is with just 1 or 2% electric cars, but they were already a problem. So to make them all electric is just crazy. You can't do it. They will learn, by bitter experience. This is one of these crises that we were talking about earlier. So in some ways, I'm delighted that California has done this. I wish they would do more. The crazier they are, the quicker we'll get to the end of this.
Yeah, feed them all the rope we can.
Exactly, yeah.
What's the kitty's name?
His name is Samson.
Oh, my wife walked by and appreciated.
He doesn't live up to it very well. He's a very cowardly cat.
Well, Professor Happer, this has been absolutely fascinating and eye-opening. I thank you so much for all the work you've done, for the courage of standing up, for the courage of speaking up, for using your position and your title to speak the truth when it would have been so much easier and more lucrative for you to go along with the witch lynching mob. It's really a pleasure and an honor to be talking to you. And I thank you so much for joining us and for everything you do.
Well, thank you, Saif, and you keep spreading the truth too. We need you.
Thank you, sir. I appreciate it.
Bye-bye.
Cheers. Have a good day. Bye-bye.
Yeah.